All right, this is page 217 in the IB, in the Incredibles book. All right, so uh, many people ask the question, do we ever find the value of C? And this is it. When it's called a particular solution, when we use the words particular solutions, we're actually finding the value for C, right? And they usually give you what's called an initial condition. When they give you an initial condition, and it says initial condition, but it doesn't have to be like where an x equals it. It could be any value, as long as you're given one ordered pair or two ordered pairs, depending on the number of derivatives or how many times you have to solve the problem. Okay, so the first step is find a general solution and then use the initial condition. So find a general solution and then use the initial condition to solve for C and then write the final solution including the C. All right, so here, we're going to do this one. So it says here, solve the differential equation with the initial condition. So whenever it says solve a differential equation, they're going to give you the derivative and you're going to integrate it. Okay, whether it's a particular solution or a general solution, when they say solve a differential equation, you're going to take one function and you're going to integrate it. So here, this one we're looking for g of x, not g prime of x. We have been given g prime of x, and we want to find g of x. So g of x is the integral of g prime of x. And in this case, g prime of x is 6x squared. So we're going to integrate 6x squared dx. All right, when we integrate that, so it's going to be 6x, add 1 to the exponent, divide by the new exponent, plus c. So this simplifies to 2x to the third. Yeah, just in case you can't tell, that's a 3. All right, that's a 3. All right, plus c. Now, they give you an initial condition. So that means, remember, this is g of x equals 2x cubed plus c. You're going to plug in 0 for x, so g of 0 equals -1. That means if I plug in 0 for x, I should get -1. So -1 equals 2 times 0, which is 0. 0 plus c, so that gives you c equals -1. So my particular solution, right? Remember, with g of x was 2x cubed plus c. I just found c to be -1. So my answer is g of x equals 2x cubed minus 1. Final answer for that first example here, or number 2 here. All right. I forgot that they give us very little space to do this. Let me find another piece of paper to do number 3. Solve the differential equation f double prime of x equals 3. And f prime of 2 equals 5, f2 equals 10. So I'm going to copy that over here. F double prime of x equals 3. So we're going to start with that value. All right, so we want f prime of x. F prime of x is the integral of f double prime of x. So that's the integral of 3. And when we integrate that, you get 3x plus c. So that's f prime of x. But we don't know what c is. Right? And they give us enough information to solve for c. That's the f prime of 2 equals 5. So that means that f prime of 2 at x equals 2, f prime is 5. So that means I'm going to substitute 2 for x, and I should get 5. That's how we're going to solve for c. So 5 equals 6 plus c. So c equals -1. So that means f prime of x equals 3x minus 1. Now, we want f of x. F of x is the integral of f prime of x. So that means we're going to integrate 3x minus 1. So when we integrate that, we get 3x squared over 2 minus x plus c. And they give us another condition to solve for c. It's here. F of 2 equals 10. So that means f of 2 equals 10. So that means we're going to substitute 2 for x. So it's 2 squared over 2 minus 2 plus c. And that's going to be 3 times 4 is 12, divided by 2 is 6, minus 2. So that's 4 plus c. Remember, all these are 10, so c is 6. So final answer, remember f of x was 3x squared over 2 minus x plus c, and we just found c to be 6. So that's the answer. That's the answer to number 3, the particular solution. Let's put that in there. F of x equals 3/2 x squared minus x plus 6. That's it. And then particular solution, find the general solution of f prime of x equals, find a particular solution that satisfies the initial condition f of 0 equals 3. All right, so this one's pretty straightforward. All right, let's see. F prime of x equals e to the x. And we're just looking for f of x. So f of x is the integral of f prime of x. So it's the integral of e to the x. The integral of e to the x is just e to the x. So that's f of x. Plus c. Now it says the initial condition f of 0 equals 3. So f of 0 equals e to the 0 plus c, and it's got to equal 3. Well, that's 1 plus c equals 3. So c equals 2. So that means f of x equals e to the x plus 2. That's the answer to that one. F of x equals e to the x plus 2. All right, that's this one. Ball is thrown. Okay. This is attempt number 2 to do number 5 because I made a very, very elementary mistake when I did it the first time. All right, let's try this again. All right, what is the initial ball? Ball's initial velocity. So I'm doing 5a. So acceleration due to gravity is negative 32 feet per second. That is the derivative of velocity. So if I want velocity, I need to integrate the derivative of velocity, which is acceleration. So it's the integral of negative 32. You might be wondering, why is it negative and not positive? Because it's pulling towards the ground. So we say it's negative because the distance between the object that's floating in the air somewhere to the ground is decreasing as it goes towards the ground. That's why it's negative. All right. So this is going to be negative 32t plus a constant. All right, so that's going to be our v of t. And it says here we have a velocity at 1 second is 76 feet per second, going downwards. So v of 1 equals negative 76. All right, very easy mistake to make that a positive. All right, so that means this is negative 32 times 1 plus c. So it's negative 76 equals negative 32 plus c. In fact, the first time I did this, I made that a positive, and that's wrong. Oh, you might be asking, why is it negative? Because if it's going towards the ground, right, it's such that it's downward velocity at 1 second. So it's going towards the ground. So as it's go towards the ground, the distance to the ground is decreasing. So that's a negative 76 feet per second. All right, to continue this becomes, so you add 32 to both sides. I know that's unusual for me to show my work there. But whatever. All right. So that means c is negative 44. Okay. So that means v of t equals negative 32t minus 44. All right. Now, so initial velocity, v times 0, is negative 2 times 0 minus 44 is negative 44. Right? It was asking for the initial velocity. Notice, this is what you get when you do it wrong the first time. So it's 44 feet per second. You do not have to put the negative sign. You could say it's falling, right? So you throw the ball at 44 feet per second. All right. Well, maybe we should put negative on there to show that it is going down. Okay. How tall is the building? Well, the height of the building is s of t, which is the integral of v of t, right? Because remember, s prime of t equals v of t. All right, the derivative of position is velocity. So we integrate that. So we're integrating negative 32t minus 44. All right, we're integrating that. So that is negative 32t squared over 2 minus 44t plus c. So that's negative 16t squared minus 44t plus c. And we're told at t equals 2 seconds, it was 10 feet above the ground. So at t equals 2, so that means s sub 2 equals 10. And that's negative 16 times 2 squared minus 44 times 2 plus c. So that's negative 64 minus 88 plus c. That's going to be 12, 14, negative 162 plus c. So c equals 172. All right, so that means what? We're running out of space. Let's put out, so s of t equals negative 16t squared minus 44t. Wow, can't read that. Negative 16t squared minus 44. I know you're wondering, where am I writing? 44t plus 172. That's what s of t is. Yeah, my handwriting is getting worse and worse. I am so sorry. All right, so initial height, that's s of 0, negative 16 times 0 squared minus 44 times 0 plus 172 equals 172 feet. So the height of the building is 172 feet. And that's it.